What are best practices for PyQt memory management? Imagine building a desktop application that runs smoothly without wasting resources or crashing unexpectedly. That's what good memory management in PyQt can do for you. PyQt is a set of Python bindings for the Qt framework, which means it combines Python's easy syntax with Qt's powerful GUI tools. But managing memory in this mix can be tricky if you don't follow some simple rules. First, understand Qt's parent-child object system. When you create a widget or QObject and assign it a parent, the parent automatically takes responsibility for deleting its children when it's destroyed. This means always assign a parent to your widgets and objects whenever possible. If you don't, you risk creating objects that stay in memory longer than needed. Avoid manually deleting child objects if they have a parent, as this can cause crashes or double deletions. This system helps keep your application from leaking memory over time. Next, manage object lifetimes carefully. If you create objects without parents, like temporary dialogues, you need to delete them explicitly or let Python's garbage collector handle them. Use the del statement or remove references once you no longer need an object. For more complex cases, consider using cleanup methods or context managers to ensure objects are properly disposed of. This prevents lingering objects that can eat up memory. Minimize unnecessary imports and Qt usage. Only import the specific modules you need, such as or PyQt5 Qt widgets. Avoid importing the entire PyQt5 package if you don't need all of it. Also, try to use Python's standard libraries or simpler alternatives instead of heavy Qt components when possible. This reduces the overall memory footprint of your application. Be aware of Qt's internal caching mechanisms. For example, Qt caches images using the QPixmap cache to speed up rendering. However, this cache can hold onto images even after you delete the QPixmap objects. To control this, you can set cache limits with QPixmap cache. Set cache limit. Remember that deleting a QPixmap does not always free the memory immediately because of caching, so manage cache size carefully. Optimize functions that run often or are performance critical. For example, if you load images repeatedly during scrolling or resizing, cache the scaled images instead of reloading or rescanning every time. Avoid heavy calculations or file I/O inside these functions. Pre-compute or store results to reduce memory use and improve speed. Use Python's memory management features wisely. Python handles most objects automatically, but PyQt objects wrap C++ objects that need careful handling. Keep references to PyQt objects as long as you need them, and remove references when done. Avoid circular references that can prevent garbage collection. If necessary, use weak references to break cycles and help Python clean up unused objects. Detect and debug memory leaks regularly. Use tools like Python's memory profilers or Qt's debugging tools to find objects that stay in memory longer than they should. Testing your application for leaks during development can save you headaches later. Finally, consider offloading heavy tasks to subprocesses or separate threads. Running intensive computations outside the main GUI thread can prevent memory buildup and keep your application responsive. Just be careful with thread safety and shared resources. By following these practices, using Qt's parent-child system, managing object lifetimes, minimizing unnecessary Qt components, controlling caches, optimizing critical functions, and monitoring memory, you can create PyQt applications that run efficiently and stay stable. This approach makes your desktop applications more reliable and easier to maintain over time.